Hello, and welcome to Introduction to Mosaic AI, how Databricks can help you simplify your GenAI journey. Really happy to have you with us today. Wanted to briefly touch on the point that we are going to be providing a number of different pieces of information to you, and you're not allowed to go trade on them or short stocks or what have you on them of any kind of that nature. So, pay attention to that, and let's move in. So my name is Craig Wiley. I run product management for our AI and ML group here at Databricks, our Mosaic AI team here at Databricks. And I'm joined today, really excited to be joined today by Nick, who runs our tech marketing for Mosaic, and by Nikhil, who I had the wonderful opportunity to sit next to during the keynote, knowing that all that time that they talked during the keynote about those cool FactSet capabilities, he's the guy who built them. So you'll get to hear from the three of us around some of the different capabilities at Databricks, as well as the way FactSet, a deeper dive into how FactSet used some of those capabilities. So 2023, last year, I'd say it was the year of the GenAI POC, right? There are 10,000 companies in the world that control about 90% of the IT spend. And in 2023, there were 25,000 new GenAI startups. So there were literally more than twice as many vendors as there were customers last year looking to help you get those POCs up and running, looking to impress you with their ability to build a RAG endpoint. And the problem with all of this, and what we've heard from the customers we work most closely with, was that despite having overcome the technical challenges of finally building a POC of this kind, they weren't confident putting it into production. Whether it was security concerns, whether it was hallucinations, whether it was cost concerns, all of these things have kept them from having the confidence to put this into production. Now, I'm sure many of you have GenAI models in production today, maybe customer-facing even. But it's been a real challenge for the industry to date to really start to scale that effort. And we're going to talk a little bit about that. What kept these POCs from production? What created this place where 90% of enterprises are not yet confident in productionizing these things? The first problem, as we talked about, is accuracy, right? How do I consistently get the answers I need from these models, right? The second piece was control. How do I ensure that my model is not leaking sensitive data? How do I make sure it's doing the things I want it to do and it's not memorizing PII and regurgitating that later? And then finally, ROI. Often this says cost. A lot of people talk about cost. I was talking to a customer recently. He said, Craig, I have no problem what we're paying for our GenAI capabilities. I would happily pay double that if it worked better. Right? So how do we drive that ROI conversation? How do we lower cost and increase value at the same time? So to do this, I wanted to take a brief moment and talk about the kind of evolution of GenAI development over the last, 18 months or so that we've all been up working on this. We started with this idea of, let's just ask it better questions, right? Let's do prompt engineering. Let's do prompt tuning. Let's figure out how to make those prompts perfect. And then we started saying, whoa, what if we searched for the right context and jammed it into the prompt and make these big prompts that are even better than the prompts we were handwriting, right? And that really drove that first kind of burst of energy. And then that was followed by this idea of, hey, what if not just the prompt was something I could mess around with? What if I could mess around with the models themselves? And so we started seeing customers fine-tune these models. We started seeing customers start pre-training their own models, right? We started seeing folks say, I'm going to both manage the prompt and manage the model itself. Now, there's a new wave taking place. And this new wave is compound AI systems, or agents, as you might hear it get called, right? This idea that if you're going to build really a very high-performing AI system, it's probably going to be composed of more than just a prompt, a model, and maybe some documents, right? So what are these components of a compound AI system? What are we talking about? Well, we're talking about models, and these might be embedding models. These might be task-specific LLMs. These might be big, large, kind of state-of-the-art LLMs, right? We're talking about data. That data might be embeddings in a vector database. It might be structured data that you're querying using generative AI capabilities, right? Tools and orchestration capabilities, right? Chains and agents and how we bring all these pieces together. You know, one of the most interesting questions I get a chance to talk to customers about is they'll say, oh yeah, we've got 4 GenAI systems in production. And I'll say, how are they doing? And often I get, well, good. How do you know? Well, we tried them out, right? This idea of evaluation systems, how can we make sure that these things are doing what we want them to do at scale, broadly, right? Serving systems, this new idea of this rush on GPUs and making sure that we have the critical infrastructure to be able to scale this up and scale it down. Monitoring systems, and finally governance and guardrails and controls. All of these are a part of compound AI systems. At Databricks, we've been focusing a lot on helping customers make sure they have access to the models they want to use most. Now, for a long time, we have helped customers serve custom models. Models that you built, right? Machine learning models that you built, or models that you may have downloaded from Hugging Face. For years, we've been helping customers serve these models. But more recently, we've also started spinning up foundation model APIs. Let's say that you want to try out Llama or DBRex or Mistral or one of the other hot new open source models. We make those available to you on a pay-per-token basis so that you can try them out and figure out whether or not this is the right tool for your next development project. And then finally, AI Gateway, which you heard about earlier this morning. Really excited. AI Gateway really comes from a moment just in early last year when a customer came to us and said, hey, I'm all in on Databricks. Databricks governs my data, they govern my notebooks, they govern my models, they govern all our data assets. But now there's this new class of model that's an API. What's the plan there, Databricks? And so what we've done is we've made it so that now if you go have your kind of, OpenAI account or your Claude endpoint or your Gemini endpoint, you can now bring those into Databricks and use those models with all of the tools we have to use the open source models as well. Whether it's our RAG systems, our agent systems, our monitoring, all of that is fully taken care of. And that AI Gateway system, it has rate limits, it has credential management, permission management, so you can control who in the company has access to it. It monitors every single prompt that goes out the door. I recently had a customer come to me and say, hey, this gateway is saving me a ton of money. And I looked at him and said, saving you money? Explain. And he said, yeah, I realized that 70% of the prompts that we send out to a SaaS endpoint are duplicates. We've sent them out before. And so now I've built a cache in front of it so that now we only send out the ones that we haven't answered before, right? These kinds of creative capabilities are new ways that folks are driving ROI in this space. Now, not only we talked about access to these existing models, but for many people, they need these models to be more domain specific. You may need the model to understand your space. And for that, we're excited to talk to you about our fine-tuning capabilities and our model pre-training capabilities. This fine-tuning capability, by the way, completely code-free. All you do is you go in and you choose, hey, do I want to do chat completion, continued pre-training, or instruction fine-tuning? And then you just go ahead, point us at the data set, and we'll take care of it from there, right? Let us know what model you want to fine-tune, and we'll take care of it from there. It's not, though, just the models, right? We are excited to also announce the agent framework or RAG framework that helps you bring your chains in or your agents in and use all of the Databricks services with your chains so that now you can much more easily get these systems up and running and into production quickly and more easily. And this is deeply connected to our vector search capabilities on Databricks so that you can now quickly and easily stand up RAG models kind of that afternoon or what have you, however quickly you may need to do it for your business needs. Easy to get started, easy to deploy, deeply integrated, and fully governed. Again, we are we are adamant about this governance piece, right? We will not release these capabilities without giving you some confidence that you can control who has access and what it is that it's going to push out. Now, it goes beyond just training the model, and we saw this earlier today in the keynote, that we're excited to announce function calling and our tools catalog. This allows you to start giving your model tools. You know, we all know that these LLMs often are not very good at arithmetic, right? You can ask them basic arithmetic questions and they'll often get it wrong. But give the LLM a calculator and it does the arithmetic great. It can run a calculator great. So I'm reminded of my childhood of, hey, you're not going to have a calculator forever. No, you're right. Now I have a large language model that I need to give the calculator to. But giving the calculator to this model, it can now do this. Now the calculator's an easy one. What if instead we give it code writing capabilities or code interpretation capabilities, right? Internet access or data queries, file search, et cetera. All these different capabilities that now allow you to really supercharge the model performance. We see open source models competing with the most state-of-the-art models when they're combined with functions and function calling. Now, as a part of that, evaluation has become increasingly critical. We've seen that customers, I think back to last summer, just a year ago, reading blogs about training models and folks saying, yeah, we trained it for a while and then we just checked the vibe of the model. And for someone who's been in machine learning for years, I was sitting there going, wait a minute, is vibe a new measurement? Is this, I know R squared, I know RMSE, I know, what is this vibe you're talking about? And it was just that, it was the vibe of the model. Now, we're excited to help bring structure to this with our evaluation systems that give you full trace logs of every single aspect of your agent, LLM judges to help you evaluate the performance of each step of your agent, and then peer labeling as well. So your peers can look at it or other humans can look at it, and you can use those LLMs to help determine what you want to prioritize the humans to go chase. Now, I'm going to take a moment and have Nick come up on stage and walk through some of these capabilities.
Fantastic job. There we go. Now I can hear myself. Cool. All right, so hopefully a lot of you made it to the keynote earlier and got to see Casey's awesome demo. This is going to be similar. But I want to really just run this home that what we're kind of seeing evolve is the shift from general intelligence over to data intelligence. And I'm going to show you kind of what that means in practice. So first, we're going to jump into the AI playground. This is kind of the easiest, quickest way to go test different foundation models, custom models, all sorts of stuff on Databricks. And so we're actually going to add another model here. We're going to test DBRex, and next to it, we're going to do, let's say, Meta's Llama 3. And here we can ask it general knowledge questions, right? In the theme of the keynote earlier, we can ask it, how do I bake a cookie? And both of these are probably going to give me a pretty good idea of how to bake a cookie, but that's general knowledge. That's not specific to your company, to what you're trying to do. Now, what if we asked it something like, can you compare the sales of my San Francisco and Los Angeles stores? Now all of a sudden it's like, sure. Here's how you would go about doing this. Here's a plan, go have fun, right? But now imagine if this wasn't general intelligence, but it was data intelligence. So what we're actually going to do is we're going to go over here and we're going to take one of these tool-enabled models and we're actually going to give it tools that we have defined that let us do things like look up the sales for our stores. So like Casey showed us earlier, we can do, we can just go to our catalog, and so we have retail prod, and we in the AI world here, we're brave, we like doing live demos, so bear with me. So what we're doing there with just that little magic function there is just saying, look, all of the tools that we've registered in this catalog under the AI schema, now the model has access to. So now, when we ask it something like, can you compare the sales between my San Francisco and Los Angeles stores, now something kind of magical happens. The model has access to not just these functions, but also the metadata, so it knows how to use them. So it goes, it does some chain of thought reasoning, and it goes, well, first, I need to get the franchise ID for the San Francisco store. Okay, I've got that. Now I have another function that takes an ID and it goes and it looks up my total sales for these stores. I can do the same thing for the Los Angeles stores. Now it brings the two and combines them together, and now all of a sudden, you have an intelligent answer that's based on your company's data because the model is now able to access it securely, which is really awesome. We can even go a step further. So we can add an extra hosted function that I made that will actually go and pull social media reviews. So franchise reviews. So this is my custom function, and I can ask it something like, what are customers saying about the Outback oatmeal, which is one of the cookies that we sell? Right, so now it's gonna go, and it goes, okay, well, in order to answer this question, I've gotta go look up a bunch of reviews. So it's actually going, it's doing the retrieval step, it's gonna bring back the 10 most relevant reviews, it'll summarize for you, and it'll say that customers are saying the Outback oatmeal cookies are soft, chewy, utterly addictive with a perfect balance of spices. Awesome. Right? For us, that's a pretty high quality answer. But imagine that this is not one model deployed, one person querying it, but rather something you have out there working in a system where all of your franchisees are asking these questions. How can you actually go validate that what the model is doing is accurate? And for that, we're going to look at the trace. So something Craig brought up earlier, because MLflow is kind of baked into all of this, we have something really cool called MLflow tracing. For all of these deployed chains, models, AI agents, compound systems, we can actually go through and get a much better understanding of what exactly happened throughout the whole chain of calls. In this case, right, we can say, oh, well, the input was what our customers saying about the Outback oatmeal. On the left, you see all of the different steps that ran. And if we want to go and see exactly what happened, we can go into the retrieval step, for example, and we can expand that, and now we can see these are exactly what was retrieved. These are reviews that it is basing its answer off of. So if you do end up getting feedback saying, hey, your model's hallucinating, hey, it gave me a really bad answer, you can now have a trace to go look back, see exactly what happened, and you know what you might need to tweak or fix. So that is what we're calling the shift from general intelligence to data intelligence, and we're helping you all build these yourselves. So I'm gonna give it back to Craig to take back over.
Thanks, Nick. It is really exciting. These are the kinds of ideas that, I think we all imagined computers. I think of, Star Trek as a kid and watching and thinking, I ought to be able to just talk to it, right? And now we're starting to be able to get to a place where maybe that is something we can do. Now, all of these capabilities are great, but I guarantee there's someone in your company who's nervous about this. There's folks in your company who are saying, oh, I'm not sure this is a good idea. I don't know if this can be trusted. I don't know if we can fully control this. And so with that, we are bringing both guardrails into our system so that you now have the ability to have guardrails. I had a customer recently say, what do I need guardrails for? These models, they tend to be pretty good about not saying terrible things. And I reminded him that these models may often love his competitor more than they love him, and whether or not that might be something he would want to protect against, right? Unity Catalog puts you in control of all of this. The models are fully governed, right? The embeddings are fully governed. The tools are governed. The access is managed. All of these pieces are logging every single thing they do so that you can both debug it and audit it to make sure it's performing the way you would want to. Now, we talked at the beginning about this importance of ROI. And what are we doing to help drive this ROI? And here's the deal. This slide is not a single, hey, we're launching the ROI tool. This is a list of things just, hey, our foundation model APIs make it so that you don't have to spin up a whole, you just want to try out a model, right? Saving you money. Our model serving auto scales as your demand increases and decreases and scales to 0 so that you don't leave the cluster on over the weekend by mistake, right? These capabilities, model training, fine-tuning these faster, smaller models that are more task-specific and can get done precisely the work or the jobs you want to get done. without having to have kind of the size of a model with much more extraneous information, right? We've found that we can run remarkable capabilities off 7 billion, 30 billion parameter models, even getting, kind of state-of-the-art types of capabilities if we fine-tune those models for the problem that we're asking them to solve, right? Model quality, the model quality systems that were just shown, and the trace logs, and the judges, the human judges, and the LLM judges both help increase the value of these models by giving you better results. And then finally, monitoring, right? Continues to help ensure that these models are performing the way you want to and tracking their performance over time. Now, if you think about how all of this works, I wanted to briefly just look at an agent structure and how this might work, right? If I were wanting to do, for example, a common ask I get is, hey, I want to do RAG on tables, right? Or I want to do text to SQL. And so you can think about this idea of, what do I need to actually do? I need to establish a chain of thought, right? I need to create an embedding of my prompt so that I can use that to go hit my vector database to find not kind of the answer to the question, but to find the tables and columns that will be most relevant, right? So I'm actually doing a vector DB or a RAG lookup on the metadata of my structured data. Right? And by doing it on that metadata, I now know this is the table I should hit, these are the columns I should hit. I can bring those back and I can send those along with the prompt to a SQL gen or a code generator model. Right? Now all of a sudden it has the tables and the columns already for it. It can now go and write the SQL to answer this question. I can then run that query, make sure that query works, right? And then assuming that query works and I've got the output, I can take that original prompt and the output table, send them to a model and ask to give us an English kind of summary of what all has taken place. We have tons of customers building this on top of Databricks today, right? This is something that we, whether it's kind of, network health for cellular networks or, understanding your manufacturing or your healthcare or your financial use cases, we see this being used across various industries and domains. Now, to dive into a more real world kind of agent and kind of the real performance of how this works in the wild, I'd like to bring Nikhil up to discuss FactSet in greater depth.
Hello, everyone. Thanks, Craig. So today I'll be talking about text to formula. As the name says, generate a formula using a natural language query. So before getting onto it, quickly, who is FactSet, right? What do we do? FactSet actually empowers financial community with a digital platform and then solutions which can actually deliver global financial data, analytics, and open technology. So we have buy-side and sell-side clients, both including wealth managers, private equity firms, which actually gets benefit from our comprehensive and connected content, and use our dedicated client support as well. So the strategic focus of FactSet in this year is to leverage advancements in AI, particularly GenAI, and see can we actually help to improve the efficiency of the client's workflows and drive growth there. And we are working on doing integrations of AI in APIs, search, and chatbots to efficiently make those workflows better, and they can actually able to see those progress by themselves. So automation and optimizations are one of the key growths here. Let's get on to the problem statement, right? So there are two big things in here, like FQL and screening. Those are kind of FactSet proprietary languages to actually pull data. We call them FactSet query language or screening. And a simple example about what we are trying to do, right? So instead of building a formula or FactSet clients build this formula, so it's going to actually take time. And another important aspect is formula discoverability, right? There are many formulas, many libraries we have around, 20,000 formulas, which is kind of segregated into multiple, 40 data sets or 40 libraries. So which one to use, which one to pick it from? So it becomes very, very tough. Rather, clients spending more time in building this, we'll try and actually use the latest technology, which is GenAI, and try and see, okay, can I calculate the revenue of last 2 years for a particular company on a quarterly basis? So this is a formula which you can actually easily see it. I'm going to actually brief it out. It has two components, a ticker component and the formula. You can actually see those like arguments talking about like what is the periodicity, like quarterly basis, and the years which are represented there. Nearly half of all questions which comes to our help desk actually is asking about like how to build this formula, what is the right formula. And all of our FactSet applications are powered by data, right? And one of the main thing is like how should I actually pull these data efficiently, and clients can actually spend more time on building the business logic rather than building these complex formulas. How did we go on building these things, right? As any company or any engineer goes, okay, let's build a simple RAG system, right? It's a standalone model. What do we need? An input and an LLM model, and let's tap into our knowledge sources, which actually has all those like formulas, descriptions, definitions, and a few examples to actually help them to understand like what kind of formulas to be generated, and the output is the formula. Will it work? So I've kind of purposefully kept the name like big LLM, right? Because we have to keep it LLM fluid in the sense that like we should not kind of stick to one specific model. Every few weeks or every few months, we'll actually see those getting changed, new models getting released, whether it's proprietary or open source. Very soon, we actually hit the quality ceiling. Okay, lots of issues, whether it's design, accuracy, it's very non-modular. It's a one big single comprehensive prompt with multiple objectives to solve. So these LLMs are smart, but they're not smart enough to actually follow every instructions what you have written in this big prompt, right? Very soon, if you're going to actually hit the roadblock, okay, I'm not able to, why my LLM model is not able to listen to my instructions, right? These are, and other design issues could be non-scalable. As I just mentioned, like many formulas similar to your use cases, there could be many different kinds of data sets and knowledge sources which you need to kind of streamline into it. Becomes very hard in my use case, like, okay, write formula, write arguments, and I cannot actually tap into my own proprietary APIs. Like we use our own API for ticker resolution, date resolution. Those are standard to our own FactSet data sets. I cannot use them efficiently in a single big comprehensive part. That definitely take a hit on the accuracy. And another big part is hallucination, right? So these are like very standard problems. Everyone is going to actually face it. So what did we do, right? Instead of building one big model, let's actually do a divide and conquer, right? So we choose the model, the best model for each of these tasks, right? Not one big standalone. Let's actually break it up, right? There are three components: query processing, a custom retriever, which actually has a vector DB lookup. And these are embeddings. These does not actually have the smartness of adding your own business intelligence data. So that's why we kind of embedded on top of it as a post-processing LLM re-ranker, right? You got the results, let me re-rank based on certain criteria, which is kind of part of the business intelligence, what we actually fit in. So without that, it becomes hard. Embeddings does not actually have all those business knowledge. And in the end, once you have got the right formula, let's actually see if there are any hallucinations. So we kind of do some kind of hallucination check or filters. Sometimes you can even do corrections. Sometimes they actually go a little off. You cannot fix them. Sometimes they are slightly off because of the type of question. These are not standard like questions like, okay, what is the formula? Like these are free form natural language queries. Anyone can say anything. Hello, good morning. Can I actually have that formula? And blah, blah, blah. I wanted that in that cell references, because these are the one what I showed you. It's called FactSet sidebar syntax. It's supposed to execute in like spreadsheets. So they can say like, okay, I need that formula. I need all those arguments in those different cell references. So by breaking them apart into multiple pieces, I can concentrate. Okay, the first step is to make sure like identify all this, something called like query decomposition. I understand what library I need to actually pull the formula from, and I need the specific data item, like what we call as formulas, from the vector DB to actually look at. I don't need all those extra like buzzwords or like keywords, which are not keywords, like those are like filler words which are not supposed to be there for the vector DB lookup. That kind of deteriorates your like lookup factors. So we do that as part of retriever. You do the lookup only with the reformulated query, and then actually use your like business logic, try and re-rank them, make sure like you actually get the best one which actually does serve the purpose of the query. And then hallucination check and Building these things, right, you're kind of actually attending different aspects of it. So right now, we have made it something called prompt families. Like these are like dedicated prompts, which actually kind of clear directions, no ambiguity in there. That's one of the biggest thing, like we should not be ambiguity in different tasks. By making have the best model for each of these tasks, you can actually able to like track individual errors. You can able to, okay, there's an issue with the query processing, let's solve that. There's an issue in the vector DB, okay, there's an issue with the descriptions. Let's actually talk to content owners. Let's actually, okay, can we improve the quality of it because we're not able to solve this? So by breaking them apart, you're actually making the model to go more wiser. It seems like model is working, but without the good quality of data or the data intelligence thing, it's very hard for us to actually achieve the accuracy of it. Let's see this in a different block workflow diagram. So now the query processor, we can actually see the different LLMs which are being represented here. Like I've actually mentioned like big LLM, LLM2, and LLM. Each one of these is doing its own tasks. So we kind of break them into like multiple pieces. As I said, error tracking is one of the prime piece, which kind of, as Craig mentioned, sometimes we do overlook. It's not the vibe. We have to go and check the actual quality of it. So we actually used MLflow to try and track for each of the steps, make sure like they're actually doing the best. If not, we have to go make sure like those things are actually happening. When we initially started, you might have seen in the keynote presented by Patrick in the morning, the accuracy was very like less, around like say 55 to 60%, and the response time was okay, like it was around like 15 seconds. So when we did lots of experimentation to come up with this architecture, the accuracy, we definitely got a boost. You can see like it's like 26% increase. And because of these complex prompts, you tend to actually increase because you will be using sophisticated models to make sure like there's less of hallucinations, more about the focus on what exactly you want to actually achieve. So there's a bump in the accuracy. So what should we do? So let's head back, right? Let's step back and see, okay, now we have got the initial requirements. We have to transcend our initial requirements and actually go beyond something. And we have to start doing like fine tuning of these models. And that's one of the key factors which actually helps reduce the response time by like 10 seconds. Can we do better? Yes, you can. Let's actually work on improving with more fine-tuned models, which we actually decreased our response time by over 60%. That's huge for us. Like these are kind of near real-time APIs. We are spending a lot of time in actually using this data intelligence platform, trying to actually have all these things. To actually make it operational success, we need this platform, right? So you go about, have this capability to give to respective content owners and ask them to, can you actually improve the quality of the prompts? Can you actually improve the effectiveness of the formulas? Can you help us guide through it? And that's exactly what the platform is going to do. So like we have the respective ownership given to them, and that's kind of divide and conquer again, try to actually help improve the model quality of it. And lastly, same thing, we make the whole system automated, self-service capable, and towards the integration of these open source models, we actually make this model more cool and more easier to actually maintain. From this, I'll actually give back to Craig, and thanks everyone for being here.
Thanks, Nikhil. Getting to work with FactSet is a real joy. And if you haven't had the opportunity at Databricks, getting to work closely with our customers is really how we are successful in building these products. And so I would encourage you to reach out to the teams. If you've seen things that are interesting, reach out to your sales teams, reach out to the product teams and the engineering teams. We'd love to get your feedback. We'd love to get your input. I've listed some other cool GenAI topics up here on the board. This is all we've got for today. So thank you all very much for coming. We hope to see you at some of our other sessions and tomorrow at the keynote as well. Have a great day. Thank you.